This is the second supplemental video for Chapter 5, the Intermediate Modeling with Simio. In this video, we'll be focusing on Model 5.2, the Enhanced PCB Assembly. In the first video, we focused on Model 5.1, and as I mentioned in that video, we'll be using that same model. So if you haven't done that already, or if you haven't completed Model 5.1, you need to do that before you pick up with this module. So let's have a look back at our model that we did in Model 5.1, and we have printed circuit boards arrive. They go through a placement operation followed by an inspection and then a probabilistic branching. So if we run the model here, we can see entities moving from placement to inspection. You can't actually see them going to good or bad, but in the previous video we did an experiment where we showed that they move in the proper proportion. One thing that I wanted to mention before we continue with this video is, let me let it run for a second and get a little bit of a cue. Let's see if we can do that here. There we go. There we go. That's particularly confusing in the textbook to new users, and that has to do with the Simio object family. So you see the object definition, object instance, object run space definitions here in the book, and then there's a figure that shows exactly, or that illustrates that point. But I wanted to take a couple of seconds and illustrate that or discuss that with respect to this model, and hopefully it will make it easier to understand. So basically, when you talk about a Simio object, when we use the term object, there are actually three different types of objects, or three different object things. What you have in the library is what's called the object definition. So if you look at the server, for example, the server object definition is right here. Once I place the server in the facility view, then I've created an instance. So here I have two separate instances of this object definition. And then finally, we have what's called the run space. And in the object-oriented world, sometimes that's called a realization. And so in this case, we have realization for the instance placement and a realization for the instance inspection when the model is running. Similarly, when we have our printed circuit board, our PCB entity that you can't see while I have it running is an instance of the model entity object definition. And then here are two separate run spaces of that instance. So we have the object definition, the object instance, and the object realization. And in general, when we're discussing this, we often just refer to the concept of an object without differentiating between those different types. I'll try to differentiate when necessary, but keep in mind that there are these three different things, and we'll continue talking about that over the next couple of videos. So Model 5.2 is an enhancement of Model 5.1, our printed circuit board assembly. And we're going to be implementing three different enhancements to that model. First of all, we're going to introduce rework. So before, when we look at the model, going the wrong way here, we had placement and inspection, and the result of the inspection was either a good or bad. And now we're going to introduce the notion of rework, where some proportion of the boards don't pass inspection, but they're not totally bad. They can be reworked. And so, in fact, we're going to say that the 92% that were previously good are now consist of 66% good and 26% that require rework. So rework's a separate operation, and here are the processing parameters, triangular 2, 4, 6. Once they finish rework, they are fed back into placement and are treated exactly like newly arriving boards. So that's one enhancement. The second enhancement we're going to do is introduce worker schedules. So the placement machine is automated, but the inspection and rework operations are both done by humans. And so we're going to explicitly consider the hours of work that the operators work, including meal breaks. So you work 8 hours and you have time for lunch or breaks. So we're going to incorporate that. We're also going to incorporate the fact that that rework is only done during one shift. So while the other operations are 3 shifts a day, the rework is only 1 shift. And the third enhancement that we're going to do is incorporating machine failures. The placement machine is automated, so we are going to incorporate calendar-based failures. So we have a time to failure and a time to repair, both of which are stochastic, and we will implement that in our model. So here is Model 5.1, And instead of creating a completely new model or copying the SPFX file to a new file, we're going to use the capability of having multiple models inside the Simio project. And before I go through this process, note that this is not covered in the book. So um, pay close attention. So here's what I'm going to do. Here's my model, and you can see it defined right here as model. I'm just going to rename this. It doesn't matter, you don't have to rename it, but I'm just going to name this one Model 5.1 so that I can differentiate between that and Model 5.2. Now I'm going to go to the My Simio project folder here at the top, and you can see what that opens up is the project view. And so I have selected Model 5.1, and I'm going to do a Control C, Control V. So Control C for copy and Control V for paste. And note that you can't right click, so there's no context menu for cut and paste. You have to use the keyboard shortcuts. And you can see now we have a copy. We have Model 5.1 and we have Model 5.1.1. So I'm going to, of course, go in here and rename this to Model 5.2. And now we have two copies because I haven't changed it at all. So we have two copies of the same thing. So I can execute this file, or I'm sorry, execute this model, or execute this model, and the experiments copy and everything. So we've essentially made an exact copy of the previous model. And now we will go through and make the three enhancements that we did for model 5.2. So the first enhancement that we'll do is adding rework. And again, we have 26% go to rework, 66 go to good, and 8% go to bad. And then after rework, the reworked boards are routed back to um, placement, and the processing time of rework is triangular 246. All right, so let's have a look. This is a pretty simple change. We're going to zoom out just a little bit. And we're just going to grab another server and we're going to place it right here. I'll go ahead and rename this Rework. And then we'll connect from inspection to Rework. And then from Rework back to placement. There we go, back to placement. So you can see the connector now is going to send boards there. And so now we need to fix our probabilities, our selection weights. So it was 92 and now it's going to be 66. And this one's going to remain 8. And now the remaining 0.26 will go here. And so now we have 26% go to rework, 66% are good, and 8% are bad. We'll go ahead and change this. So this is the processing time. So it was, let's see, triangular 246. So there we go, triangular 246, and then they go back in to placement. So one note here is that this is the first opportunity we've seen emerge. So we have entities that are coming from source one, and then we have entities that are coming from rework, and they're both coming to the input node of placement. And the problem said treat the boards identically, and so they'll just both merge into here and be handled as if they were coming from a single location. So we can run this and check this. And if we were really doing this problem, which you should definitely do at home, you want to go back and check as we did before and make sure that what we're actually seeing is 26% here, and then this one is 66 and 8. And I'm not going to do that here, but you should definitely do that on your own. So if we've set this up correctly, we should now have boards that go through the rework and then back to placement. And note that they can go through the rework multiple times because there's nothing stopping a board that goes through rework, again through placement and inspection, from probabilistically, again, 26% chance of coming down through rework again. So one thing that we're generally interested in is counting things like that. So I'd like to be able to count when a board leaves, how many times has it gone through placement? And so this is our first example of what we would call a user-defined statistic. So we're trying to track something that Simio doesn't have any way of knowing that we'd want to track. So for our previous statistics like time in system and number in system and things like that, the Simio objects in the standard library did that for us automatically. This example, it doesn't know how to do that, so we have to do that. And so the thing to remember here is that we're trying to track, we're trying to say when a board leaves, we want to be able to ask that board how many times were you processed. And so that's an indication that what we want is an observational statistic that the observation is based on individual printed circuit boards. And so that leads us to the realization that what we need is an entity state and a tally statistic, which is an observational statistic. So let's do that. So I'm going to go to PCB here. And so what I need to do is somehow track for each printed circuit board how many times it goes through placement. So the first step here that I'm going to do is I'm going to go to Model Entity. And again, make sure you're at Model Entity and not Model. And I'm going to go to Definitions, States, and I'm going to add an integer state. So here I am at States. Again, make sure we're at Model Entity, add an integer state, and let's just call this times processed. And so that's going to create an entity state that will allow us to track the number of times processed. Next thing we're going to do is we're going to go back to model. Again, make sure you're at model 5.2. And now what we need to do is update that state. So every time the board is processed, I need to increment that value. So we're going to do that right here on the placement step. And if you look over here on the properties, we have what are called state assignments. And so the state assignments allow me to make a state assignment at particular times within the processing sequence. And then what we want is right here at before exiting. So note when I click on one of these down here in this little help area, it tells me what that is. So this is an optional state assignment when an entity is ready to exit. If we do after processing, it's while it's still in the processing station before it transfers to the exit station. So really either one of those two would work, but I'm going to pick that one. So before exiting, I'm going to make a state assignment. Let me make that a little bit smaller. And what I want to do is I want to have model entity times process. And I want to increment that, or I want to increment that value. So model entity plus 1. Oops, I must have typed something wrong. Times processed. Let's see, what did I type wrong? Model entity processed. So times processed plus 1. And again, note that I went through that pretty quickly, but we had that nice coral color that said, okay, you've done something wrong. And because we don't have an error, then there's not a syntax error. It knows, okay, well, it recognizes this state and it recognizes this expression. So there we go. And so now, as an entity goes through, every time it's processed, we should increment that value. So that's the second step. First step was define a model state. I'm sorry, an entity state. Second step, increment that value. Now the last step is we need to create our tally statistic. So again, make sure we're selected on model, go to definitions, and now we need an element. And the element we need is up here in the statistics. That we need is a tally statistic. And this time, I'm going to call this one num times processed. Num times processed. And so that creates the tally statistic. And the last step that we need to do is we need to record the observation. And there are two ways to record an observation. We can either use a tally step, which is what they do in the book, which I'm not going to do that, or we could make use of the tally statistics on the input node to the sink. So when boards leave, either through the good or bad, I'm just going to go to the tally statistics and say, on entering the output node, let's add the value. And what we want to pick is num times processed. And the expression we want is that state statistic, the state value that we are recording. So model entity times processed. So num times processed is the tally statistic, and model entity dot times processed is the entity state that holds the value that we would like to record. So I'm just going to cut and paste this because I know I'm going to do this again. That was on the good boards. We also want to record the same thing on the bad boards. And so I'm going to go to tally statistics. On entering, I'm going to create a new one. The one that I want is num times processed. And then I'm going to paste that value in. And so when we run now, so let's just run this in interactive mode. So I'm going to just fast forward here. I still have it set to 1200 hours from the previous video. And when we go to results, the first thing that we see here is a user-defined statistics or user-specified statistics called num process. And so this tells me that the average time that a board was processed was 1.3551. So a natural question we should be asking ourselves right now is this number correct? Well, we're essentially saying that each board is processed 1.36 times. So if we think about a 26% probability of rework and accounting for the fact that some boards can be reworked multiple times, it sounds plausible that it's 1.36. You can also check it by if you realize that the actual answer is 1 divided by 1 minus 0.26 or 1 divided by 0.74. So you can check that and make sure that you understand where I got that expression from before going on. So I want to spend just a couple of seconds talking about that concept of a tally statistic that we just did. So I'm going to use the whiteboard here. Let's see, I need to, I guess, create a new whiteboard. And the way I like to think about this as, think about my tally statistic as a bucket. So here's my tally statistic, and here's my handle for my bucket. So this is tally statistic. And the way this works is I throw observations, THROW, throw observations into the bucket. And then at the end of the run, I aggregate and analyze. And so in our model, the concept of throwing the observations was when we used that tally statistic property with the two input nodes, right? So I said, okay, that's the analog to throwing the observations in. And the tally statistic itself represents the bucket, and the entity state and the incrementing of the entity state is what actually set that value. So again, just a mental note that I use when I think about, well, what exactly, how do I interpret what a tally statistic is? And we'll see that that's fundamentally different than state statistics or output statistics that we'll get to a little bit later on. Okay, so the next thing we want to add is worker schedules. And let me reiterate here that the purpose of the video is to focus on the Simio aspects of this. So you definitely want to read about this in the book also and talk about the incorporation of worker schedules. So let's go in here and have a look. So we go back here to the outline, we go to resource schedules, and basically what we're saying is the rework and inspection are both done by humans. And humans generally work in shifts, and they also take breaks. And so in our printed circuit board example, we're going to assume that we have 3 8-hour shifts per day for a total of 24 hours. And each shift includes a 1-hour meal break. So a worker's day is really 9 hours, but an hour of that is a meal break. So first shift we're going to say is 8 to 12 starting, and then 12 to 1 for the meal break, and then 1 to 5. Second shift is 4 to 8 with a meal break at 8 to 9, and then 9 to 1 a.m. And third shift is 12 a.m. to 4 a.m., at 4 a.m. to 5 a.m. meal break, and 5 a.m. to 9 a.m. The second part of the work. And so you'll note, first thing you'll notice that these overlap. So these overlap by an hour on, when the first worker gets off at 5, the second worker starts at 4. For simplicity, we're going to assume that when a worker gets there, the first hour they spend is doing administrative stuff. So we're not double working, is what I mean. Now we could easily incorporate that into the model, but I just don't want to do it for this very first model where we use schedules. So to implement this in Simio, Simio uses what are called, what do we have here? Schedules, resource schedules. And so Simio resource schedules are based on the Simio clock, which goes from 12 a.m. to 12 a.m., a 24-hour cycle. And so when you look at our inspection resource, for example, which works 3 shifts minus these 3 1-hour meal breaks, instead of starting with first shift, which starts at 8 in the morning, we have to start at 12 a.m. because that's when the Simio clock starts. So we basically have to take this shift schedule and work it into a 24-hour schedule that goes from 12 a.m. to 12 a.m. And what we're saying is, what are the resource capacities? So from 12 a.m. to 4 a.m. we have someone working, then we have a meal break from 4 to 5, and then from 5 to noon we have someone working, and then noon to 1 we have a meal break, and then 1 to 8 someone working, and then 8 to 9 a meal break, and then we only have 1 hour of that cycle to get back to midnight of 1 hour. So again, have a look at this in detail and make sure that you understand how you get from here to here, because the next thing we need to do is then implement this in Simio using the resource schedule feature. Okay, so let's implement that. Let's implement the schedule feature. So I'm back at my model here, and I'm going to go and make sure you're a model 5.2, by the way. I'm going to go in data, and under the data tab, you can see a number of options, tables, bindings, and so on. And what we want is work schedule. And so a quick note, the interface to work schedules has changed a little bit since the last edition of the book. Particularly, we added something called table-based work schedules we'll get to a little bit later on. So it looks slightly different. But basically the idea behind defining Simio schedules is to create what's called a day pattern and then create a work schedule based on those day patterns. And so the default, we have a standard work day. You can see a standard 8 to 5, which is 8 to noon, 1 to 5. Okay, and so we're going to define our new day pattern. We'll just leave it at day pattern 1, and we're going to input the values that we had from our table, from our table right here. So we have this time that we'd already sort of identified, and what we need to put in are all of the values that are equal to 1, because Simio assumes that you have a 0 value if you don't have another value. So we are going to start at 12. So the first thing we're going to do is start time at 12 for 4 hours, and so we're going to end at 4. And we're going to have a value of 1. Let me see if I can make this a little bigger. There we go. Then we are going to start at 5 a.m. So we'll just increment that for 7 hours to 12 p.m. So I jump, I need that to be 12 p.m. Let's see if we can get that there. Well, I want 12 p.m. Well, we'll just make this p.m. There we go. We'll just make that 12. I don't know why we can't cycle through it, but for some reason we can't. Now we're at 7 hours, and then it has a value of 1. So I'm going to add another one that's from 1 p.m. I'll just type this. Seems a little bit easier. 1 p.m. for 7 hours to 8 p.m. 8 p.m., that's 7 hours. It has a value of 1. And finally, from 9 p.m. To 12 a.m., which is 3 hours, it has a value of 1. So from 12 a.m. to 4 a.m., 1. From 5 a.m. to 12 p.m., 1. From 1 p.m. to 8 p.m., 1. And from 9 p.m. to 12 a.m., 1. So if you just add up these hours, you can see that we have 14, 17, 21 hours. And so that's the day, the 24-hour day, minus our 3 hours of meal time. So now I'm going to go back up to my week now that I have my day pattern defined, and I'm going to define a new pattern-based work schedule, and I'm going to call this one inspection schedule. Inspection schedule. And so now we need to tell Simio what days we have. So what I'm going to do is I'm going to change this to 1 because we want all the days to be the same. We didn't say anything about weekends, so I'll just make that 1 because Simio will repeat. So now we have day pattern 1, we have 1 day, and it will repeat over and over and over. So one more time, we defined a day pattern, which is the capacity that we want to have for each hour of the day. And then we created a schedule where we have 1 day defined using that day pattern, and then Simio will replicate that over and over. Note that we could do 7 days, so if we didn't want to work on the weekend, we could do that also, but we didn't specify that. So now I have an inspection schedule, and so the last step I need to do is go back to inspection and say, instead of having a fixed capacity, I want this to be based on a work schedule, and the work schedule that I want it to be based on is inspection schedule. And so now, when we run our model, what we would hope to see is that the inspection is going to go off shift at the times where the meal breaks occur. So you could go back and look at where those meal breaks occur in our time. I guess the first one happens at 4 a.m. So here we are at 12:50 a.m. So let's increase the speed just a little bit. So let's go up to 50. And you can see the time down here is going. So here we are. It's still going a little bit slow. So let's increase that one more time to 100, and then I'm going to try to pause it right here at 4, somewhere in between 4. So there we are at 3 a.m. And we're going to stop that and note that I'm at 412, and you can see that the inspection has now changed color because the state has changed from busy to off shift, and we can also see the queue building up here. And so again, this is something that you would want to go check the entire schedule rather than just checking this one meal breaks to make sure that we've incorporated all of those things correctly. So in addition to the inspection, taking the meal breaks, remember that rework only works on second shift. So if we go back and look, we have first shift here and second shift and third shift. Second shift is from 4 to 8 and then 9 to 1 with the meal break in between. So we need to create a second schedule, second day shift, and I'm sorry, a day pattern and schedule that implements just the second shift only. So let's go back to Simio and go back to data, definitions, and let's create a new day pattern. So here's our new day pattern. We'll just leave it at day pattern 2. And we can see that this is from 12 a.m. to 1 a.m. we have a value of 1. And then from 4 p.m., let's see, 4 p.m., if I can type that, 4 p.m. to 8 p.m., 8 p.m., let's see here, p.m., 4 hours we have a value of 1, and then finally 9 p.m. Till 12 a.m. For 3 hours. So here is our 4-hour workday, and the 1-hour gap here is between 8 and 9. So between 8 p.m. and 9 p.m., that's day pattern 2. And then we create a pattern-based schedule, and this is going to be named Rework Schedule. And so again, we haven't said anything about weekends, so we'll just use one day pattern or one day and make it day pattern 2. So day pattern 2 is second shift. So we go back to our facility now. We just apply that to rework. Say, okay, rework does now follow a work schedule. And this is the rework schedule. And so when we run now, we should see we're in the middle of second shift because it starts at 12 a.m. But what we should see then is it goes off shift, which it just did because it turned white. And now all of the rework should back up because there's no one back on shift until, again, the start of second shift. And here we are. It looks to be about 4 a.m. and second shift ends at 1 a.m., starts at 9 p.m. So, well, is that right? 1 a.m. ends at 1 a.m., starts at 5 p.m., 4 p.m., somewhere. You can look back and see, but you can see that this is all going backwards, and so the line's backing up because this is off shift. So again, this is something you should definitely check and make sure that you've implemented this correctly. I'm going to leave that to you to go back and do that, but you definitely want to do that and make sure that our 2 schedules are implemented as they are designed. And the final enhancement that we have is machine failures. So we handled the 2 manual operations, the inspection and rework. The placement machine is automated, and so it's subject to random failures. So we just jump over here to that section, and this section goes through the types of failures that the objects in the standard library support, in particular 3 types: calendar-based, event count-based, and processing count-based. For ours, we're going to have a calendar-based failure, and a calendar-based failure is basically predicated or defined by a time to failure expression and a time to repair expression. So we're going to say that our placement machine fails about every 6 hours of runtime or of uptime, and it takes approximately 30 minutes to repair when it does fail. And because these 2 are highly variable, we're going to assume both of them are exponentially distributed. So essentially, this is a very simple thing to implement. I'm going to go back in my Simio model to placement, and we can go down and look at reliability logic here. And we're going to create a set of calendar-based or calendar time-based failures. And then, of course, it asked me the two questions that we have. So uptime between failures, and we said that was going to be exponential 6. And again, of course, it's bold because we've changed from the default, 6 hours. And the time to repair is also going to be exponential. This time it's going to be 30 minutes. And again, make sure you change those time units so you're going to have a time to repair of 30 hours. And so now we're going to say the placement machine is going to fail approximately every 6 hours and then take approximately 30 minutes to repair. And if we run and we have a failure, at some point we should have a failure, and we're going to see the placement machine is going to change into the failure state. Let's see if that happens here. We're only at 2 hours here, so we wouldn't have expected it to happen yet. Of course, it's random, so you don't exactly know when it's going to occur. We'll just sit here for a little bit and see if we can see it change in state. We can also monitor the other components. We can see that our rework is off shift, and so it's continuing to be that off shift color. Okay, so no failures yet, and we're at 9 hours. There we go. There was a red somewhere around 9 hours. So you can see that it changed state. And a quick glance of how you can tell what state it's in. If I go to the placement or any one of the objects, I can look up here in the symbols ribbon, and if I pull that down, you can see we see the starve state, which is the typical gray. If it's processing, it's green, which we've seen a lot. And we've seen off shift before, which is white, and now we see the failed state is of red. So again, you want to take a look at this and make sure that you're confident that it's implemented the logic that we specified back in the problem assignment. So that's all I'm going to do in this video, the Simio components. And the book talks about in detail about model verification, and you absolutely want to go through that process and make sure that you can verify the model. So developing expectation and then making your model match that expectation through a set of experiments. And remember, before you go, don't forget to save your model. So we created 2 models now in our project. So we could save it under the same name that we did in the previous video, which is model 5.1, but that's really no longer correct. So I'm just going to do a save as, and I'm just going to save it as model 5.1.2, or let's do dash so it's not confused with model 5.12. So now we've saved our model. We've saved our project that includes 2 models, model 5.1 and model 5.2.